Hello and welcome to the second part of our video on section 16a, and now we're going to talk about what a normal is. So the normal to a straight line is a line that's perpendicular to a straight line. So if the blue line is the line that I care about, then the red line is normal to the blue line. There's 90 degrees between those two lines. And we know from grade 9 math that if the slope of the blue line is 2, then the slope of a perpendicular line is the negative reciprocal, or negative 1/2. So we might be asked to write the equation of the normal to a particular curve, and we might use derivatives to help us with that. So just like tangents are straight lines, every normal is also a straight line. And every straight line can be expressed in this y equals mx plus b, or sometimes it's referred to as y equals mx plus c form, where m stands for the gradient of the curve, and, and the value of m can be calculated by finding the derivative of the function at the x value given. If we want to write the normal for a particular curve, then we would use the gradient of negative 1 over m, or negative 1 over the derivative of f of x. And then we can find the value for b using algebra, just like we did in the previous examples. What's important to remember is that the normal passes through the same point on the graph as the tangent. So whatever our key point was that we were using to write the equation of the tangent, we're using the same point to write the equation of the normal. So for example, if I want to find the equation of the normal to the tangent of the function f of x equals root x plus 3x when x equals 1, I'm going to start by finding the slope of the normal. And to do that, I need to find the slope of the tangent. So I'm going to rewrite my function in exponential form from radical form. Then I'm going to apply the power law and the constant multiple rule so that I can drop the 1/2, keep the base, reduce the exponent by 1. And here I can just pull out the 3 and take the derivative of x, which is 3. The derivative of 3x, which is 3. I end up with this derivative. Now, if I plug in that value the point that I cared about, remember that we cared about when x was equal to 1, I can plug in that value and find the slope of the tangent is 7/2. But if I want the slope of the normal line, or we call it the gradient of the normal line, I'm going to take the negative reciprocal of 7/2, which is negative 2 over 7. Then I'm going to write the equation. I need the slope, which I found is negative 2 over 7, and a point. Well, I care about when x equals 1, and I can find the y value when x equals 1 by subbing in 1 for x here and here. So when x is 1, it turns out that y is 4, and therefore the point 1, 4 is on the normal. Then I can substitute in the values that I have for the gradient of the normal, as well as the x and y values here. So subbing in 1 for x and 4 for y, and do a little bit of algebra to find out the value of b is 30 over 7. So we can write this as y equals negative 2/7x plus 30 over 7. And we're going to look at some more complicated examples in our next video, so stay tuned for part C of this video. Thank you and have a great day.